Okay, next problem. We're given points -8, 3, -4, 7. We're asked to sketch a line from this point to this point, not including this point, and then a line segment from here to here, not including this point but including this one, and then a segment from here to here, including this point and this one. So how do we do that? Well, it's a little tricky to indicate those points, and apparently it's a little tricky to draw a straight line. Okay, so we go from here to here, not including this point. However, we got to go from here to here, including this point. So we have a double indicator on this point. We have a circle indicating that one of these segments doesn't include this point, and a point indicating that the other line does indicate the point. So it's included on the second line, not the first, and it means this point. So the point included on the second line, but not the first. And then we're asked to write the equations and inequalities that define this function. Well, I'm not going to go through the details of it, but it's fairly easy to find the equation of this line. I believe this line segment is part of the line y equals x plus 11, for at least the duration of this line. And here it's the line simply y equals 7. And you should hopefully have no trouble understanding why that's true. Y is 7 here, y is 7 here. The slope is then clearly 0 because you have 0 rise between 7 and 7. There's no change. And the y equals mx plus b, the m is 0, and b, clearly this line is going to continue. Well, right there is the y-intercept. The y-intercept is at b equals 7. So it's y equals 0x plus 7. And that just becomes y equals 7. And that's the equation of the line that this segment is part of. Now, this equation only applies to this segment here, and this equation only applies to this segment. So how are we going to write the equation of that function? Well, we write it this way. Y equals, we have a split definition. Okay, y equals x plus 11 for part of the duration of this function, and y equals 7 for another part of the segment. Now, where is it equal to x plus 11? It's equal to x plus 11 between x equals -8 and x equals 4, not including x equals 4. So we say that -8 is less than or equal to x is less than 4. And now we've defined exactly where the line segment coincides with the line. It's for x values between -8 and 4, including -8, not including 4. And where is it that y equals 7? Well, that's for -4, less than or equal to x, less than or equal to 0. Okay, because from -4 to 0, including -4 and 0, so we have the inclusion here, we follow this segment. So, fairly straightforward problem, but you do need to know how to do that. Problem 8, and I've labeled these problem 7, problem 8, so you can keep them straight. I've got room here, so I'm going to use the board space. We're given that a runner is doing 4 meters per second when t equals 8 seconds, and 5 meters per second when t equals 13 seconds. And we're asked to find the average rate of change of the speed with respect to clock time. Now, the average rate of change of one quantity with respect to another is the change in the first quantity divided by the change in the second. So this is equal to change in speed divided by change in the clock time. And make sure that we got, we need to move this back just a little. Okay, so what's the change in speed? What's the change in clock time? Well, the speed goes from 4 meters per second to 5 meters per second. So the change in speed is 5 meters per second minus 4 meters per second. What's the change in clock time? Well, the clock time goes from 8 seconds to 13 seconds. So the change in clock time is 13 seconds minus 8 seconds. And what's that equal? Well, this is 1 meter per second divided by 5 seconds. And we want to express that as a simple fraction. The 1 over 5, of course, can be left as 1/5, or we can calculate it as 0.2. And I guess I'll calculate that as 0.2. And that's going to be meters per second divided by seconds. Now, meter per second divided by seconds is meters per second multiplied by reciprocal seconds. Because we're dividing by seconds, it's the same as multiplying by 1 over seconds. So that's 0.2. Now the meters per second I've written out linearly here, but I've written the meters over the seconds here so we can clearly see the fraction. And divided by seconds, that's times reciprocal seconds. And when we multiply that out, we get meters over seconds squared. Numerator times numerator, denominator times denominator. So that equals, if we move up this way, 0.2 meters per second squared. And that's our average rate. So average rate calculations are very simple. If you remember that the average rate of change of one thing with respect to another is the change in that first thing divided by the change in the second.